Fine, guys. Let's start. My screen visible?
Yes, Santosh.
Okay. So yesterday we have started discussing the missing values, right? So what we understood, missing values needs to be handled because most of the machine learning models don't perform well with missing values. That's fine. So what are the basic ways which you can handle missing values, guys? One is you can simply remove them. One is impute them. Okay. First we'll see removing the part. So now when coming to remove, so first thing is, yeah, so we already started checking this notebook. Yes. Okay. Yeah. So this is our data set, and here we have seen. Yeah. So when you do df.isnal.mean into 100 or without 100, so this is a missing percentage values. Okay. These are the missing percentage values. Now, yesterday we are trying to understand this code. So what is this code? This code is giving you the columns whose missing value is less than 0.05 or 5%. I am considering the columns where that column has missing values less than 5%. Why less than 5%? Because my idea here is to drop or remove. Agree? So I can do only when there are few missing values. Okay, if a column is having only few missing values, less percentage of missing values, only in that case I can drop. Because if I drop if a column is having, let's say, 30% of missing values. Okay. Now, if I drop, what does it mean? I'm losing a lot of information. Why? Because fundamental point you need to understand regarding the missing value is when I am saying drop, I'm not dropping column, guys. I'm dropping rows. Okay. Never and ever in machine learning concepts, you will drop a column. You never do that. Okay. Always it will be rows. Okay. As I said earlier, I'm again repeating. Let's say you are having 1,000 rows, okay, and 10 columns. Okay. So if you drop 2 rows from this 1,000 rows, that's still fine. 998 rows, that's still fine. Not a big difference. But if you drop 2 rows from here, it's just 8 columns. Okay, that means you lost so much information. A new column is like a new dimension. Okay, to understand the data. So even if you drop one column also, you are losing a lot of information. Let's say you are dropping this 6 column. You are losing very crucial information, like which person, which gender is dropping. Agree? So that's why it's always the rows which we are going to drop. First thing. Now here also, when I say you are dropping wherever you are having age, if you're dropping means you are dropping all the rows. Okay, fine. Now coming back over here, we are considered we got these 5 columns where whose missing values is less than 5%. Okay, as you can see, 2.5, 2.22, okay, and 3, 0.3. Okay, these 5 rows. And these are my value counts. Now, what you're going to do, you're dropping. How you are going to drop? Just drop NA will drop the rows, guys. Okay, drop NA will just drop the rows. Okay, and if you see, yeah, so there's a detailed documentation. So there are many different ways also how you can drop, but if you don't mention any parameter, so it will drop. Okay, it will drop the complete row. I mean, even if one value is NA, then also it will drop. Okay, or you will have like determine if a row is removed by when at least one NA or all NA. Okay, so if any of the NA is present, if all of the NA, then only drop. Okay, so you can mention any or all. Okay, what does this mean? See, yes, you are having any or all. That means you are having a row. Okay, it's having, let's say, some 7 columns. Okay. So any means even if one column is also NA, then drop the whole row. That means if any of the column is null, drop the row. If you give it as all, only if all the columns, that means entire column, so entire row is NA, then only drop the row. Getting?
Yeah, Santosh. So
Okay.
no, so basically we'll use for any.
Yes, no rule, but by default is any.
Yeah.
By default is any. If you put all, that means only if the all the values in that row is NA, that means the complete row is NA. Obviously, it, you need to remove, because if the whole row is NA, that means there is no information, then what is the point? So we are going to drop. That's fine. Okay. But usually use NA. That means even if any one value is NA, you're going to remove that. Okay. So yeah, so now df calls dot drop NA, you have done. And now this is saying drop, you have to drop NA by length of actual DF. Okay. So this is length actual DF. This is drop NA DF. That means after dropping, how much percentage of the data is left? It is 89.6. Okay. Earlier, if there are 100 rows, now there are only 89 rows. Means 11 rows. 11% of the rows got dropped. Okay. Now you need to understand this 11 percentage. Okay. Now what does this mean? Now this is my, I've considered only my these columns. Okay. The 5 columns. Okay. Now you need to understand this 11 percentage is coming from what? Is coming from this data set. That means from this data set, I've dropped 11 percentage. That means combining all these columns, there are 11% of the columns. That means anything is possible, guys. What I mean to say is, here, for example, 11 in this row, this enrolled is NaN. So this will be dropped. Okay. Agree. And let's say in some other column, okay, some other column, this is NA and this is also NA, for example. Okay, then also it will be dropped. Like that, overall combined, there are 11 percentage. Okay, yesterday was calculated, it was around 2000, right? So 2000 of the rows got dropped. Clear? Hmm? No?
I understand, Santosh. Now, if we run that query above 5%, less than
Mhm.
0.05%, so it will be now zero, right?
It will be
Because
zero, correct. Every no correct. There we dropped all the null values. Now you'll not have any null values. That's correct. Yeah. So if I want to show you, yeah. So now when I do this, you got sample, right? Okay, and okay, and if I use this, see, you will not get any columns.
yeah, Santosh, got it.
Okay, fine. And also earlier the DF shape is 19,000 and now it is 17,000. Okay, and also one more important thing you can check is, now if I do is null, okay, and sum, now this is not having any missing values.
But number of columns should not change, right, Santosh?
Now, correct,
The,
number of columns should not change, but the reason what that is a good point, but the point which I'm saying here is we are considering to drop. Okay, ideally what will happen? So you are having, see,
but
ideally what will
basically we
happen?
will perform on entire data set, but only for this purpose you have shown us only for 5 columns, 5 to 6 columns.
Correct, exactly. So you can consider, usually what happens is we'll consider all the columns, okay, all
Yes.
the columns, and when you are dropping the rows, selecting these columns, right? So it will drop the corresponding values from other columns also.
Yes. Yes.
Okay,
Yes.
fine. So that is how usually it happens.
Correct.
Okay, but since I'm just showing you the removing part, so I not consider other columns. But usually
Okay.
you'll have other columns also. Let's say column one, column other columns. Its corresponding rows will also be dropped when you're dropping regarding this column.
Okay. Got it.
Okay, fine. And once you do is null dot sum, it will show you the values. So it is all zero values. That means there are no null values now. Okay. So this is how you can also check once again. So first you have checked there are some missing values, then again do drop, then again you check now there are no missing values. This fine. Now dropping is easy, but once it is dropped, you need to check few things. Okay. So first thing is whether the distribution has changed or not. Okay, because there should not be much change in the distribution. Okay, because before dropping, if it is like this, and after dropping, now let's say it is something like this. So something has happened, right? So the distribution is changing much. So that is not a good sign. Okay. So that you need to see. Okay. So here, for example, if you see new data frame, if I see the histogram, okay, there are considering three values. So one is city development index, experience, training hours. Okay. And enroll university and education, these are categorical. Okay, so that's why it not show the histogram. Okay, so these values, okay, city development, experience, and training hours. Okay, so those three histograms are these. Okay, now this is what after removing the null values, new df, we'll compare it with the old df. Okay, so if you see in the original data frame, this is df of training hours. Okay, in the original data frame, if you are plotting the training hours, okay, with bins equal to 15, and that is red color. And in the new data frame, same training hours with green color. Okay, so if you see, so if you see the small red color over here, is it visible?
Yeah. Yes, Santosh. In the top.
In the top,
It's
right?
on top. Yeah.
So it is overlapping. Okay, that means the new and old are almost equal. Okay, the new and old are almost equal, but the old is little more because you are able to see red. That means the green is a bit less over here, right? For example, in this place, if you are seeing red, that means green is a bit shorter than red. That's why you are seeing the red. Otherwise, green might have overlapped that. Okay, why green is bit shorter? Because green is from the new data set. Okay, and in new data set there are some values missing. Okay, so the count will be bit less, so the height will be bit short. So that's why a small portion of the red is visible over here. Getting?
Yes, sir.
Getting this point? So why here red part is visible? Okay, because in some places the red is old one. Okay, on top of old one, if you are we are drawing this new one. Okay, not on the top of, but when you're drawing both of those, in some places this green color, okay, is not overlapping the red color. Because why? This green is from the new df. In new df is created by how? By dropping some missing values. Okay, that means the count of this df will be more by when compared to this count of new df by 2000 values, right? So since because there are some values missing in the new df, okay, some values in the sense some rows are missing, so that's why this green color is not overlapping completely. Okay, but that is negligible. Wherever you see this small red values, right? So there, that means some rows got removed. Okay, so but more or less the distribution is exactly same, so there is no change in the distribution. Is this clear?
Yeah, Santosh.
Okay. And second thing is, if you want to see individually, okay, so this is DF only training us plot, density plot, not the histogram, okay, and the new DF and the DF, okay. So red and green, you're not able to see any red over here. It is almost the same, okay. And if you see the city development histogram, okay, and city development histogram individually, here also mostly more or less same, okay, only very minute differences. That's fine. And this is the plot density plot, okay. So this is also fine, okay. And this is experience, okay. Experience is also same, so you can see just minor changes, okay. Here also just small changes, okay. This is also fine, okay. So distribution wise, okay, distribution wise we are good, okay. Because why? When you are removing the data, okay, okay, 1 second. Okay. So when you're missing, when you can remove the data, what all we have seen is, so we need to check the distributions. You need to check, okay. Distributions we have checked. Second thing is, if you see the value counts, okay. So these are the value counts, DF. This is the original value counts. And after removing the null values, this is a new DF is CCA. Now there is one word related to this null values, guys. It's called CCA, which is called as complete case analysis. Okay. So it means that you are analyzing every column, okay, respected to the missing values, okay. So usually whenever we are dealing with missing values, right, so it is called as complete case analysis, okay. So there's no new concept, it's just a terminology, okay. So this is for the old DF and this is for the new DF, okay. And as you can see, the value counts, number of enrollment and full-time, part-time, okay. And from where are we getting? For the enroll university, okay. For the, do we have the enroll university? Where is my enroll university? Okay. Yeah, see, wherever you are in numerical values for city development and experience and training hours, for these three, we have seen the distributions. Okay. And for categorical values, the enroll university and education level, okay, we are going to see the value counts. Okay. Over here, if you see, yeah, so the for enroll university, this is the original. In enroll university, there are three value counts, guys. One is number of enrollment, full-time course, part-time course. Following. So if you see the value counts, or you can see the unique. Okay. See, no enrollment, uh, full-time course, part-time course. Okay. These are three categories in this enroll university column. Okay. So in this column, these are the original value counts. This is the new value counts. Okay. Almost same, 72, 75, 19, 20, 0.06, 0.6. Agree?
But original should be more, right, Santosh? Or did I miss anything?
That's a good point. The value counts, percentage observed by, okay, concatenation of, let me think, give me a second. Number of the value counts. Okay, we'll try to analyze, but that's a good question. If you see df dot shape, sorry, okay, and new df dot shape, okay, okay.
Yeah, here we can see reduced. Yeah.
Yeah, correct only, right? I think because the length is also, the overall length is decreasing. Okay. Huh. See, if you see here, 13187. See, the count is 13187. Okay,
Yes.
this is more. Okay.
Correct.
But the overall count is 19158. Okay.
Okay. Okay.
I agree that that's correct, that when we have removed some null values. Okay. But how many values we removed, guys? Total 2000 values.
2000 nearly.
Okay. But
Yeah.
all those 2000 will not be from the enroll university. Okay. Roughly some values will be removed. Okay. In some rows regarding the enroll university will be removed. And some will be some other column.
Okay, but here no enrollment, full-time enrollment or row-wise data only, right?
Correct, row wise data. Over
Okay.
here in the new data set, if you see, there are 12632.
Correct.
Okay, 12632. So in the numerator, 1000 change is there.
Correct.
Okay, but in the denominator is what? That overall length. Overall,
2000.
how many rows are removed? Overall, how many rows are removed? As 17,000 rows are removed. I mean, 2000 rows are removed and left out is 17,000. See, I'll tell you again. The value here is what this value is what? This value is value counts dividing. I'm dividing by the length of the data frame.
Yeah. That is understand, Santosh.
This is also
But
length of new
only,
data frame. Okay.
yeah, this one is
So,
not understand.
okay.
Like
So now,
2632.
yeah. So overall, yeah. So this is the old one. This is the old
Correct.
one. 13817
Correct.
1. Now, if you compare the new one, simple max. So numerator denominator. Here, for example, if this is kept constant, okay, if this is kept constant and if you are reducing only the numerator, obviously the value will decrease.
No. I'm not talking about those values.
Mhm.
Orally 2000 rows are reduced. That's why in denominator it's 19,000. It's the original data set, and new data set it is 17,000. That is fine. But in the numerator, that is 13,817. It's a before deletion of records. Why it is? I mean, it should be also. I mean, like here 12,632. That is, I mean, I got confused. Why it is 12632?
Why it is 12632?
Yeah.
That's what. So I'm saying, how can I tell you? In some cases, if there are sorry, just give me a second. I will tell you an example. See, for example, where is this column? Oh, so this is different data set, right? Okay. Where in the original data frame, okay, where is my original DF? Yeah, this is a original DF. Okay, so here you are having 13817. Now, when you are removing the null values, okay, so when you are removing the null values, there is no rule. Okay, there is no rule that every time this particular category, what is that category? What is the category we are looking for? No enrollment. That should get removed. Full-time course might removed.
Okay.
Part-time course might have removed. Okay, so that means, wait, I will tell you in this.
Okay, got it. This no enrollment, full-time, part-time are categories under enrollment university column.
Correct. So if you see, what is this value? 1182. Okay. Or for example, let me. Okay, so 1590 total. The difference between 3757, 3449, 1198, 1101, 1712632.
Yeah, got it, Santosh. I understand.
Okay, so
Yeah.
these overall values, right? So see,
Yeah.
I got your point. So let me explain you this way. So you are thinking that, so when there is 2000 values reducing, okay, in the new data frame. So why in the new enrollment there is only 1000 reduced? Okay, see, it is, for example,
Yeah,
let's say,
it's showing category wise.
category. For
Code.
example, the
Yeah.
city development index is null. Okay. Now
Yeah.
what will happen? I'm dropping this row. So when I'm dropping this row, what particular category is dropping in this enroll university?
No
In this
enrollment.
case, no enrollment. Okay. Now,
Yes.
for example, this is also null. Now, what particular category is dropping? Full-time course is dropping,
Full-time
not the
course.
enrollment, but the count of
Yes.
enrollment will not affect when I am dropping this row.
Okay.
Only the count of full-time course will affect, right? When I'm dropping this row,
Yes. Yes.
the count of
Yes.
full-time course will affect. Like that, it might have happened that most of the yeah, that's the reason when I'm dropping 2000 rows overall, that does not mean I'm dropping
All
2000
2000 no
non-enrollment.
enrollment. Yeah. It's a
Okay.
combination of all three. Yeah. Yeah. Got it.
Yeah, it should be a combination of all.
Yes. Yes. Yes.
Okay,
Yes. Santosh.
fine. And okay, is your question clear?
Yeah. Yeah. Clear. Clear.
Okay, yeah, but that's a good question actually. Yeah. So now, where was I? Yeah. So here, if you see that is a reason. That is a reason because in the new data frame, the denominator is reducing by 2000. Okay, but these values will not reduce that much. Okay, because only some categories are missing. When you are removing rows, okay, from no enrollment, some values will be reduced. For full time, some values will be reduced. From part time, some values will be reduced. Okay, but overall there will be 2000 values reduced. Getting?
Yes, Santosh.
Okay, so and also if I just show you, just give me a second. What is that? In what is that column name? Enroll university.
Yes. Enrolled university.
What are the total unique values of those? Okay. The 86 values. And the difference of these should get the sum. No enrollment. Difference is 1236 full time. Okay, and 386 is 1976. Okay.
If we combine all three, if we
No,
combine
no,
no
even if you
enrollment,
combine, even if you combine all three also, you may not get, because see, that's the reason, got it. So even if you combine the all three also, actually the values difference is, see, actually
yeah,
the value difference is like 19158. Okay.
correct,
If you see the difference of this is around 2000.
correct.
Okay, but if you see the individual difference over here, the number of enrollment, okay, is 1185. It is 308.97, and the actual null value is 386. But if you add, you will get only 1976. The difference is, in some cases there might be a combination of these two. That means it is having enrollment,
Okay,
okay, and also full time,
got it, got it. Yeah,
okay, part time, and
both comes
also
under
full time.
only one row.
Right.
Correct. Okay.
Okay, fine. So continuing, so you're having original, this is a CCA, and you can see it's not of much difference. Okay, so the value counts is also almost same. Okay, and same thing for the education level. Okay, so for education level also, if you see, mm, for education level also, okay, graduate, masters, high school, and PhD. So these are the values. Okay, and before original and CC are almost same. Agree? So value counts is the second thing you need to check while you are removing the null values. Okay, so see, I am not saying that you will be doing this every time. Okay, but if you want to do a detailed analysis, so you can check all this. Okay, so initially check what are the missing percentage of the missing values. Okay, then consider removing only those which are having usually less than 5% of the values, and then check the distributions. Okay, before and after. Okay, and see the plot densities. Okay, and then also see the value counts. Okay, if it is not changing much, then you are good to remove. Is it fine?
Yeah, Santosh.
Any doubts, Meghana?
No, sir, no doubt.
Okay, fine. So that is regarding the removing guys. Okay. Now coming to imputation. Okay, coming to imputation. As I said, there are two ways of imputing. So one is regarding the univariate, considering only on one column, and second is a multivariate. Okay. Now in univariate, the thing you have from sklearn is a simple imputer. Okay. So using simple imputer, you can impute the values. Okay. And as I said, there are two types of variables you will face. One is numerical, one is categorical. Obviously, if it is numerical, okay, you can use mean or median filling. That means what? Yeah, I'll tell you. Okay, and second thing is you can fill it with a random value, or you can use it for the end by something called end of distribution. Okay, and if it is categorical, it will be having mode missing, etc., etc. Okay, let's start. So now coming to univariate, as I said, if you consider only one column to fill missing values, it's called univariate, guys. Okay, and if you consider multiple columns, it's obviously bivariate. Okay, and there are few pros and cons. Okay, the pro is simple. You can just, it is very simple to execute. Okay, and here also, if the percentage is usually less than 5% missing values are there, then you can impute this. Okay, but there are few cons over here. That means the distribution changes. Okay, it might create outliers and covariance and correlation changes. Okay, what does this mean? Okay, now we'll try to understand. Okay, so for numerical values, as I said, okay, you can fill with mean or median or random value impute or end of the distribution. Now what does this mean? See, you are having a column. Okay, let's take age column itself. Okay, and there are some value missing. Okay, now when I'm saying I want to fill this missing, so first thing is to remove. That is done. Okay, forget about removing. Okay, now we don't want to remove. Okay, I want to fill these values. Okay, fill all these missing values. Now the simple way is to fill it either by mean and median. But what mean and what median? Okay, the mean of other columns. Now let's say overall there are 1,000 values. In that, let's say 100 values are missing. Okay, now to fill this 100 values, what I'm going to do is I am taking the mean of remaining 900 values. Okay, remaining 900 values mean, okay, I'm taking, and that value I'm replacing with this 100 values. Similarly, I can do with the median also. I'm taking the median of remaining 900 values, and that value I'm replacing it with these 100 values. Is it clear?
Yes.
Okay, that is one way. Okay, we are going to see code for everything. Okay, this is one way. And second thing is random value. Okay, instead of doing this, okay, just to make the model understand that this is a missing value, usually, not usually, in some cases, we can also fill it with some different value. That means we can fill, you can take some random value, let's say some 99. Okay, let's say some 99 or 999 value, or some -1, -10. Okay, and just fill with this value the whole missing values. Okay, and third thing is end of the distribution. Okay, you have these values, q1 and q3 quantiles, right? So from the IQR concept we understood, right? So using those also you can fill. Okay, we'll see with an example, then we'll understand. Okay, so just give me a second. Yeah. Okay. So here now you're having the I'm taking this simple data set, okay, Titanic toy data set, okay, age, fair, family survey, small data set, and train test split, simple imputer, column transformer. Okay. Now when you do see here, when I do info, okay, you got this, but is null dot mean, okay, or is null dot sum, okay, anything you do, it will tell you the number of percentage of missing values. Now if you see, the age is having 19% of the missing values. Agree? Age is having 19% of the missing values. And fair is having 5% of the missing values. Okay. Age is having 19% of the missing values and fair is having 5% of the missing values. Okay. Now, obviously, this needs to be handled. And here we are going to do some imputations. There is no removing concept. Now, survived is my output column. So I'm dropping that and creating my X and Y and passing this X and Y to my train test split. Okay. Because the point here is, and also, yeah, I think I missed in telling you important point. Whatever you have done here, right, in the missing values concept, so this value, see this fill NA, drop NA, see drop NA is from pandas, right? Guys, this is from pandas, this is a pandas function. Okay, see, no, sorry. See, these functions, whether it is encoding or missing values, dropping or filling, usually you can do it in two ways. One is pandas and one is sklearn. Okay, pandas is simple Python function, sorry, Python library. sklearn is a machine learning library dedicated to. Okay, now this drop NA, okay, this drop NA is a pandas function. Okay, but now coming to imputation, this simple imputer, what we have seen, this column transformer, everything is a sklearn library. Okay, this is a sklearn library. That is, whenever you are doing something related to sklearn library, obviously you need to first split it into training data, test data, apply these imputations on training data. That means you do fit and transform on training data and apply the same thing to the test data also. Just do the transform the test data also. Okay, that thing you need to keep in mind. Okay, that's why when I'm trying to impute using simple imputer. So that's why what I did, I have divided it into train test split. Okay, this is my train data, this is my test data. Okay, fine. And in my training data, this is my age and fair. Okay, getting in the overall data, this is my percentage. Okay, but after dividing, obviously some missing values will be going into train data, remaining will be coming into the test data. Agree? After that, my training data missing values percentage is this. Okay, you might think again why it is 19 here, why it is 20 here, because this 19 is compared to the overall data set. Okay, but now this 20 is with only this 712. Okay, in 712, in just 712, if you're having more missing values, obviously the percentage will be more. Getting?
Yeah, got it, Sanjay.
Okay, if more missing values, let's say the division happened in such a way that most of the missing values fell into this training data. So obviously the percentage will be more. Okay.
Yes.
Fine. So now comes the actual thing. Okay. Now the point here is this one. So we are going to see filling it with mean and median values. Okay. Now, first of all, you need to calculate the mean values. How you are going to calculate the mean values? Now, xtrain is my input data. So xtrain of age. Okay. Xtrain of age dot mean will give you my mean age. Okay. And xtrain of age dot median is my median of age. And xtrain fair mean will be mean fair. Xtrain fair median will give you median fair. I'm just collecting the values and putting. Clear this step?
Yes.
Okay. Now you see the way how you can fill the values is using this word called as fill NA. Okay, is word fill NA. Fill NA is again a pandas function. It's not a sklearn function. Okay, we'll see with sklearn simple imputer also, but this is not yet the simple imputer. This is just a pandas function. Okay, just like how you had drop NA. Okay, just like how you had drop NA, you also have something called as fill NA. Clear?
Yeah, Santosh.
Okay, just like how you had drop NA, that means it will drop, and this is just a which is drop NA, so this is just a fill NA. Okay, so if I just show you fill NA means what? Null values. Drop NA means drop null values function. Okay, and fill NA means fill the NA values. And there are different ways how you can fill, guys. Okay. Now, if you, yeah, so here I'm saying extend dot fill NA, and inside that, see, observe this. I'm saying extend dot age. Okay, that means what? Age column in the extend, fill all the missing values. How many missing values are there? 20% of the missing values are there. Okay, fill all those missing values with what value? With this median age. Now, from where I'm getting this median age? This one. Okay, agree? And create a new column for that with the name of age median. Getting? No, not getting. See, we are having this extreme. Okay. Inside this, we are having what is, let's assume we are having one column called as age. Okay. And let's say there are some missing values. Now, this number one line code will do, it will create a new column called as age median. Okay. Age median, such that it will create a new column with all the values, but wherever you are having the missing values, those will be filled by fill NA. Inside this fill NA, I am doing median age. This value we already calculated, right? So this all missing values will be filled by this median age value.
Yeah, got it, Santosh.
Got it? Similarly, you're also doing age mean. Okay, similarly, instead of age median, I'm doing age mean. Okay, here I'm filling it by mean of the age, this value, mean age. Okay, very simple. So wherever you are having the missing value, just fill with some value. If you give 10, okay, now the point here is, interesting point here is, this fill in is a pandas function, and for this you need to just mention some parameter. If you say 0, it will just fill wherever the missing value is, it will fill with 0. If you give 100, it will fill with 100. If you give -10, it will fill with -10. That's it. Simple. But here, instead of randomly filling, we want some logic, right? So that's why I'm taking the mean value and taking the median value and filling it. Okay. And what is the logic? If you think with common sense, what is the logic is, now you're having a whole column. Okay, and out of this 1000, there are 1000 values and 100 values are missing. Okay, now as I said, it is missing. I don't know, I have no idea what these values could be, because I have not seen those values and they're missing. But if you think with common sense, the best thing I can do here is, I can take the 900 values and take an average of that. Okay, because I don't know what values those could be. One way is it just doing the equal justice. I'm just taking the average of the remaining values and filling it with these values. Okay, that's why these values are important, because these are statistically backed values. Okay, mean value, median, mode, all these are statistically backed values. That means they have some statistical evidence. Okay, so instead of filling some random value, instead of filling with lowest from this 900 values, okay, instead of filling with the lowest value or instead of filling with the highest value, I'm taking the average value. Okay, that is mean. In some cases, you can take the median. Okay, getting?
Yeah, Santosh.
Okay, so this code does the same thing. Okay, so it is creating two columns, age mean, age median. Okay, in this scenario, it is going to fill all the missing values with median age. In this scenario, it's going to fill with the mean age. Okay, same thing for the fair also. Okay, for fair also, fill all the missing values of the fair column where you are having median fair. Okay, this is a median fair. Okay, and here also median fair, fill all the missing values with mean fair. Okay, and you are creating new columns. Okay, fine. So this is just a warning. Okay, because we are like handling only one or two columns from the given data set, right? So that's why it is giving you one. That's fine. You can ignore warnings. Okay, now this is a data set which is created. See, earlier you are having only age, fair, family. From this age only, it is creating mean and median. Okay, and from this family, sorry, fair, it is creating fair, mean and fair median. Okay, and just as an example, if you see here, age is there, right? Now age, there is a null value. Okay. Now this for the same column, if you see age median, it got replaced with some median value of the remaining values. And the same thing, it got replaced with the mean values of the remaining values. If you take mean, that value is replaced in the age mean column, and median value is replaced in the age median column. Getting us, did you understand this step?
Yes, Santosh.
Sure.
Yeah.
Okay. So we are just seeing different ways of filling. Okay. I hope it's very clear because this is important. Okay. So you can fill with any value. So, but I considered filling with mean. And if I fill it with mean, this is how the column will look. That is what this table is telling us. It is telling if you fill, okay, here it is showing only one value. Okay. Because I'm taking only sample. Okay. But wherever it is having all the missing values, right? So all those places, this mean value got replaced. I don't know where, somewhere if you have some NaN value in the age column, the same value what we are seeing here will be replaced over there. Okay. Same thing. This column is saying if you fill all the missing values, wherever you are having missing values in the age column with the median, this is how the column will look like. Same thing for fair median, fair mean. Okay. Fine, guys. So once you do that, so one thing is you need to check here is see, as I said, the distribution will be changing. Okay, why the distribution will change? Usually, if you see, let's say, just with the common sense, if you think, let's say there is some age distribution is like this before. Now, what we are doing, wherever there are missing values, you are filling it with mean. Agree? Usually, what is the mean of this distribution will be? Mean of distribution will be over here. Okay. Now, wherever you are having the missing values, you are filling those values also with mean. That means this graph will slow. There is a possibility that it will become slightly like this because the values at the mean are increasing because all the missing values, let's say how many missing values are there? Let's say 200 missing values. Earlier they are NA. Now all those I am giving the value of mean. So the value, the frequency at the mean will increase. In a distribution, what are these? This is X is the values and Y is the frequency. That means how many times a value is repeating. So earlier in any given distribution, the mean will be only one. Agree? There will be only one mean. Average value will only be one value. Okay. That value I'm taking and replacing with all these 200 values. Okay. Now, the frequency at the mean is obviously increasing.
Yeah, Santosh.
Is this logic clear?
Yes, yes.
Okay. So that can happen. Okay. Now, because a new values got introduced, okay, a bunch of new values got introduced, okay, there is a chance, okay, there is a chance that the correlation and covariance might also change. In some cases, outliers might also get introduced, but we will show you a few things. Okay. So when you are having these values introduced, okay, so the first thing you should also check is the variance, guys. Okay, what is a variance before and after? Okay, so variance, how can you calculate variance? Very simple, dot var. Okay, so xtrain dot age dot var, original, and this is age median variance and age mean variance. Okay, so now these three values, if you see, original it is 204. Okay, and with the median it is 161, and with mean it is 161. Slight change. Okay, and but from here, okay, let me talk for fair and come back. Okay, for fair, if you see, original variance is this, a fair median replacement is this, and fair mean replacement is this. That means these values. Original it is 2448, after that it is 2340, 2324. So now if you compare this is for the age, and these are for the fair. Fair is okay. If you see 2448, 2340, just slight difference. Okay. But age difference is more. The variance has shifted a bit. Agree, from 204, it's 161. Okay. Which means that the imputing with median or mean for age column is not that suitable because it is creating a change in the variance. Okay, this also you need to check. It's not that you directly calculate the mean value and you fill the missing values and it's not your job is done. Okay, you need to check the if any statistical values are getting impacted. Okay, so over here, as you can see, the variance of age is shifting. Okay, but fair is fine. That means what? For age, we need to see some other methods. Okay, there are different methods, right? So you can see some other methods what you can use. Is this clear?
Yeah, Santosh, got it.
Okay, fine. So, and after that, now if you see the graphs, okay, so as I said, obviously there will be a change in the distribution. When in the previous section, so where you are removing the values, the graphs are more or less same, okay, because we are removed only few values, but here you are adding the values. That means where you are filling all the values with mean, that means the distribution of the mean will be increased a bit. So obviously you can expect a change in the distribution. Okay, so that's why if you see, yeah, so over here if you see, this blue color is age, okay, and red and green are age, median, mean. See, red and green are age almost overlapping. Why? Because you are filling the values with mean. Okay, so original value is this. Now you are filling all the null values with mean. So the value of mean will slowly increase. The frequency of the mean will increase. That's why the new values are peaked. Logic clear?
Yes.
Okay, fine. And as you can see, mean and median both are same. Okay, almost giving same distributions. And this is also, I would say, clear from this also, because both of them are having creating similar variance. That means both of them are having similar distributions. Okay, so this is how it will look like once the values you have filled it. This is a new dataset distribution, which is very different from the old dataset distribution. Okay, that is one thing. And if you see for the fair is almost same. Can you see? You're not able to see the blue color. It is overlap. That means it is almost same. It is below this green color. And that's why here also you cannot see much difference. Okay, the variance is not much. Okay, a little bit of variance is there, and that is this one. Okay, so for fair, filling up with mean, imputing with mean or median is okay. Agree?
Yes.
Yeah. So that is one thing we get distributions. And one more thing, as I said, is correlations. Okay, covariance correlations. Okay, so when you see correlations, this is COV will give you covariance and COR will give you correlation. Both are same, only the ranges will be different. You remember covariance range could be anything. Okay, so that's why you can see 204, 2000, okay, 52 minus 5 something something. But correlation range will always be between. Can someone tell me?
-1 to 1.
Correct. So -1 to 1. Okay, so that's why it's always better to look at the correlation values. So over here, if you see, let's take the age, okay, with fair, the correlation is this, okay, but age median, if you take the age median, okay, the correlation is 0. Almost same, okay, but age mean, the correlation is 0.08. Okay, a slight change. And fair, if you take, that means what you are getting, right? So if I consider age, its correlation with fair is this much, okay, and with family is this much. Okay, these two are the columns I'm considering. Okay, but I cannot use age because it is having missing values. So now if I use age median, now what is its correlation with fair? 0.09, it's okay, but with family there is a small change. Okay, from -0.29 it became -0.24. Okay, and if you consider mean, there is some change over here also, here also. Similarly, fair, if you consider the fair correlation with age is 0.09, and obviously with fair it will be 1, but family it is 0.2. Okay, and for fair median it is 0.08, 0.2, or 0.0, 0.2. Okay, so from this also you can consider which, if at all any new column, it is, if it is giving you good correlation, more correlation, okay, either positive or negative, you can consider that. Okay, and yeah, so as I said, covariance, correlation, and distribution changes will be there. And also, as I said, outliers, there is also chance of outliers. Okay, so over here, if you see the box plot, okay, so this is a box plot for age, mean, and median. Okay, so age, median, and mean. Okay, now if you think of why there might be outliers, so earlier the distribution is something like this. Now what we are doing with this, there will be some range, like if you consider q1, q3, some values. Okay, now when you are filling a lot of values with some mean or median, okay, so based upon this new values, the q1 and q3 values will be impacted. Okay, because so if you see from the statistics class, what is this q1 and q3? The q1 and q3 are, what is the formula for q1 and q3? IQ are interquartile range. Okay, so q1 is what, quantile 1, quantile 3. Okay, now do you agree if I say before, before my distribution, before I'm filling the null values, q1, q3 values will be different. After I'm filling and new values are introduced, obviously the q1 values and q3 values will be different, because the percentiles, right? So if you're adding more values, the percentiles will obviously shift. New data, new values, simple. Okay, so based upon that also, there is a chance of new outlier. For example, see, there is a value over here. Before filling the null values, this might be treated as a correct value, but after filling the null values, because more values are introduced over here, with comparison to these, this might become an outlier now. Okay, because before filling the values of q1 and q3 are different, and if these q1 and q3 values are different, then IQR will be different. Now if IQR is different, lower bound and upper bound will be different. Getting, guys? See, if earlier, before filling the values, q1 and q3 will be different. If this is different, IQR will be different. If IQR is different, this lower bound, upper bound will be different. Now if you are taking the values and filling more and more values with the mean, okay, so obviously this q1 and q3 values will be different. What is q1, guys? Quantile. First 25th percentile. How many values are below the 25th percentage of the overall value? If new values are introduced, obviously q1 will be different, q3 will be different, this IQR will be different, and lower bound, upper bound will be different. So due to this, the original values which are not outliers now can be treated as an outliers. That's the point.
Got it, Sandeep.
Okay, so now you are having age, median, mean. So over here, if you see in age, earlier there are like few outliers. But when if you in place of age, if you're planning to use median, okay, so there are a group of outliers that are introduced. Okay, here also there are a group of outliers that are introduced. Okay, but if you see same thing with fair, earlier fair, there are whatever the outliers are there. If you use median or mean also, there is not much change. Can you see this?
Yes.
That is the reason from here also, from this diagram also, you can understand replacing with median and mean is okay. It is not making much difference from the diagram. Same thing you can also understand from this distribution also. Agree?
Yes.
And same thing you can also understand from this variance also. Agree? So from variance also, it is saying it is not much difference in the variance if you replace with mean and median. Okay, but we did not stop there. We came here and we saw the distributions for the fair. The distribution is also okay. We did not stop there. We came here and we saw the correlation. Correlation is also fine. Okay, and mainly we saw the outliers also. Outliers also, it is not much difference. So with all these evidences, we can say, okay, replacing with median or mean is okay. Okay, for the replacing with mean or median is suitable for fair column. But for the age column, as you can see, new outliers are getting introduced. Okay, and correlation values, I would say with correlation, it's not that easy to judge. Okay, because the values are very slight difference. Okay, but when you see the distributions, it is very evident. It is completely deviating. Agree? And
Santosh.
yes, and with the variance also, there is a major difference. Okay, so that's the reason age, it's not suitable to impute with the mean or median values. Okay, and what all we have done this, right? So the same thing you can do it with the sklearn also, and it is very simple. And this we have done it using what? Pandas fill-in. Okay, pandas fill-in, right? So but the same thing you can also do it with sklearn, and it is very simple. So what you have done, you are having the sklearn train test split is done, and you are creating two simple imputers. One is median imputer, one is mean imputer. This we have seen from yesterday. In last two sessions also we have seen it, simple imputer. So one is strategy. Over here you are having the strategy with what you want to fill. One is median and one is mean. Okay, and here you are creating a column transformer. Okay, and we are saying imputer 1 is for age, imputer 2 is for fair. Okay, so imputer 2, it's just an example. You can go, you can do the other way around also, but it's just showing how you can just simple imputers for missing values. Okay, so I'm saying you are giving some name for the imputer, and but the main thing is I want to use this imputer 1. Okay, use the imputer 1 on the fair column, and use the imputer 2 on the imputer 1 on the age column, imputer 2 on the fair column. Okay, and remaining columns pass through. Clear?
Yes, sir.
Okay, and once this, now we did not train it yet, we have just created the column transformer. Okay, now take this column transformer, just do it fit on xtrain. Okay, and that is done. Okay, so if you see here inside, it is saying I'm using the imputer 1 simple imputer with the strategy median for age, and the simple imputer with the strategy mean for fair. Okay, strategy mean for fair. And if you want to see the values also, you can see for imputer 1, what is the value? So dot statistics, it will show 28.75. That means the median value. Okay, for first one, what did we use? First one is age, right? Okay, so first one is age. Okay, the imputer 1, what imputer 1 is for median. Okay, see, don't get confused, guys. See here. So this trf dot name transformer, I am saying imputer 1 dot statistics. What it is giving? The imputer 1, that means this imputer 1, and what is this? This is imputer 1, and this is strategy is median. Okay, and on what column? Age column. So the median of the age column is 28.75. Okay, similarly for imputer 2, the imputer 2, it is on the fair column, and I'm taking mean, okay, and I'm taking mean. So what will be this value? This value will be 32. Agree? Hello? So this value will be 28.75 is for the median, and this value 32.6 will be for the mean value. Okay, that also you can get it from this transformer. That means what? It has filled with this value for all the missing values wherever you are having in the age, it has filled with this value, and for all the missing values in the fair, it has filled with this value. Got it, guys?
Yeah, Santosh.
Okay, and same thing you can do, you can transform it on the test data, train data, and test data, and this will be the new values which it will be showing in the NP-array format. Okay, so same thing you can do it on the two ways. So one thing is, as I said, you can use the fill-in concept, and manually here you need to manually calculate the values and then come here and fill it. But coming to the sklearn, you can just use the column transformer and just use a simple imputer mentioned in the strategy wise. Both thing will give you the same thing, but sklearn will be a bit easy. Okay, but even for the sklearn also, you need to again do these tests, distribution test, correlation test, and also outlier test. Okay. Fine, guys. So that is regarding the how you can impute, okay, how you can input using the simple mean median value. Okay. So in next session, we will see instead of using mean median, okay, how you can do with the random value and how you can do with something called as end of the distribution value. Okay. And next, this is numerical value, right? So if at all a column is categorical in nature, okay, for example, it is a age, sex column and male on female, okay, and if many values are missing, how can we impute this? Okay, we can use with mode, or also we can use something called as missing. Okay, that we will see. Okay, so once this is done, then it is regarding the univariate, and next we will see the multivariate, so that it will complete the missing values concept. Okay, see guys, I'm going in bit detail. Okay, in usually directly you can just okay, if if you are feeling it's a bit lengthy, right? So but this is the actual detailed analysis you need to do regarding the missing values. Okay, but usually if you want shortcut, okay, you can just okay, just go and take the mean value and fill it with the fill NA, put the mean value, and that is done. It is filled. Okay, your missing values are handled. And if you check is in sun dot mean, you will get 0. Okay, but keeping practical approach in mind, right? So you need to also be aware of these values. Okay, because if someone asks you, hey, why are you doing with mean? I know I can do it with mean. Why not median? Okay, did you what all steps you have taken, okay, to support your decision? So you can do these things. You can say, I have checked the variance, I have checked the distributions, I have checked the correlation, covariance, I've checked the outliers. Okay, based upon this, I'm able to fill the missing values. Because just keep one thing in mind, when you are filling up missing values, that means what? You are introducing new data, right? So no value is present earlier, but now you are introducing some data, right? So when you are putting some value in the data set, on this data only, the model will be getting trained. So obviously you should be very careful what values you are inserting. You cannot put some random values. Okay, based upon this data only, the model performances, predictions, everything will be based upon. So that's why you need to show some evidence, or at least you should have some clarity for yourself why I'm filling with this value. Okay.
Yeah, Santosh.
Okay, cool. Fine, guys. That's all for today. So I'm going to share the notebook for today's and also yesterday's also, and so that you can practice and let me know if any doubts. Okay. Fine. Are you good, Meghana?
Yes, sir.
Okay. Fine, guys. Thanks.